I ran into a really challenging problem while doing some testing of a Flask app. And that kind of led me to do like a deep dive into figuring out how the application or the application request context work. And so the goal of this talk really is just to provide some clarity on these contexts and really explain like why they're important to know when you're doing Flask development. So this talk is broken up into two parts. The first one kind of covers the concepts of the application in the request context and how they're handled when a request is received in Flask. And then in the second part, I'll show an example of a common error that occurs with the application context during testing. And the example I'll be going through is using Pytest. Okay, so just a little introduction to Flask. It's a web framework written in Python. It was originally written by Armin Ronacher, and now the core maintainer is David Lord. It's considered a micro framework, which I think is a term most often used when comparing it to kind of larger frameworks like Django, for example. So the micro really means that Flask is providing a core set of functionality that you need for developing web applications. And then the additional functionality that you may need, you find through this very robust and complete set of extensions that are available. So if you want to interface to a database, like a SQL database, there's Flask SQL Alchemy. If you want to do form validation, there's an extension for that. So it's really a set of core functionality that's provided. And then there's extensions that you can add in to kind of make it your own. So I'm a huge fan of Flask. I think it's a great framework. Okay, so let's jump into contexts in Flask. So first question, what is a context? So we're implementing functions that are performing calculations. They're making logic decisions, like if-else blocks. But we need data in order to execute the code. And so this data could be configuration parameters. It could be input data that you're processing, whatever it may be. And contexts are used to keep track of that data in order for your software to execute. So in Flask, these contexts provide the necessary data when you're processing either a request that's come in or if you're doing command line interface commands. So the focus of this talk is going to be on how we handle requests, but the concepts also apply if you're handling CLI commands in Flask. Okay, so starting at like a high level here, just kind of want to go through like what happens when a request comes in and is processed by Flask. So you start off with your web browser and you're making a request to a specific URL. That gets sent over and received by a web server. That web server then sends that request to a WSGI server, and WSGI stands for Web Server Gateway Interface. And so, kind of like the name implies, this is an interface between the web server and then the Python code underneath. So the web server doesn't have the ability to talk directly to Python code. And that's where that WSGI server comes in. It's kind of that layer in between your web server and then the Python code. And in this case, our Python code is a Flask application. So the request goes from the web server, gets handled by the WSGI server, which then tells the Flask application to process it. And if things go well, a response is generated. It gets sent back up to the WSGI server, up to the web server, and then your response gets sent back to the web browser, and that's what your user then ends up seeing in their web browser. Okay, so that's kind of like a high-level introduction of what we're going to be talking about. So, contexts. So, when this request is received by the Flask application, there's two contexts that we're concerned with. There's the application context and the request context. So the application context is keeping track of application level data, which is configuration variables, such as like your secret key. That's also where the logger is stored. So it's really like, stuff that applies, across like, multiple requests coming in. The request context, on the other hand, is keeping track of that request level data. So that's kind of like, in that moment, what you're processing. So that's the URL that was requested, what the HTTP method was, whether it was a get, push, post, what the headers were, request data, even the session data. So when you're working with Flask, the framework actually, it takes care of both of these contexts for you. They're both created by the Flask framework when a request is received. So normally when you're writing your Flask code, you should be cognizant of the fact that these contexts are there, but there's nothing, manually that you need to implement. We'll see later on that there are certain times, depending on what state you're in, where these contexts can cause problems, especially during testing. That's kind of a common pitfall that people run into. Okay, so here is a diagram that explains how these contexts are handled when a request comes in. And I'll admit there's a lot going on in here, so we're going to be walking through each of these steps step by step in the next few slides. Okay, so step one. So like we talked about before, a request comes in, it's received by our web server. So some common web servers would be Apache or Nginx. And then that web server passes the request along to a Whiskey server, which again is that interface between the web server and your Python application that's running. Some examples of a Whiskey server would be GUnicorn, MicroWhiskey, ModWhiskey, and you can even consider the Flask development server to be a Whiskey server. So now we're at the point where the Whiskey server has the request. And now in step two, a worker is going to be spawned to handle that request. And this worker is going to be our Flask application. So the worker could be a thread, it could be a process, a coroutine. So for example, like if you're running with the Flask development server and its default configuration, then the worker would be a thread. But for the purpose of this discussion, the actual type of the worker doesn't really matter. The key thing to kind of take note here is that this worker is going to be handling a single request. So it's just handling one request at a time. Okay, so now in step three, the Flask application is starting to execute, and the framework will automatically push the application context onto the application context stack, and it will push the request context onto the request context stack. And so this is all taken care of for you by the framework. Now, I think the one thing that may be surprising here is that these stacks are actually found in the global memory space. So they're not found as part of the worker. They're actually in the global memory space. And we'll take a look at why that's important in the next few charts. But this is kind of one of the cool design features of Flask, in my opinion. Okay. So now step four. So now execution is shifted to our view function, which is the function that's responsible for processing the request. So we've got our code ready to execute, and then we've got our application context and request context pushed up onto their respective stacks. And we need some way to make a connection between those two. And that's where proxies come into play. So proxies are what are used by the view function to be able to access the application context and the request context. So this should look familiar if you've worked with Flask before, but there's the current app proxy, which is what the view function uses to access the application context. And then there's the request context, which is used to access the request context. Now, what's really cool about these proxies is that the proxy is going to be unique to each worker, because the stacks are implemented as context local objects. So this is kind of a confusing topic, but so in Python, there's this concept of thread locals, which means data that is local to a thread. And so in Flask, they've kind of taken that a step further, and they've come up with context locals, which is data that is local to either a thread, a process, or a coroutine. So really what's local to that context. And so these proxies allow you to access those stacks, but the proxies are always unique to the worker. So you can have multiple workers here. They'll each have proxies to these stacks, but they're only going to be able to access the data that's unique to them. So this is a really cool design feature of Flask. And these proxies really make life a lot easier, and we'll take a look at how that works here. Okay, so a little bit more about proxies. So, you know, if you were to start off writing your own web framework, you may think about, you know, how would you write these view functions? And you may think, well, I'm going to pass in the application context and the request context into each view function, because that way they'll be, you know, available to use. And this is actually how a lot of web frameworks do things. So for example, in Django, you would pass in the request context into your view function. So Flask does things a little bit differently. So they use proxies like we just talked about. And so you can import current app and request proxies, and then they're just available for you to use within your view functions. So this greatly simplifies, you know, this function definition, because now, you know, there's no arguments in this case that need to be passed in, and you've got direct access to the request proxy and the current app proxy to be able to use within your view function as you're processing a request. Nice, nice features of Flask, in my opinion. Okay. So back to this diagram. So step 5, we're now at the point where the view function has generated a response, and that response gets sent back out and kind of up through the Whiskey server or web server and then back out to the web browser. And so once the response is generated, what ends up happening is that the request context and the application context, they both get popped from their respective stacks. So that's kind of like the cleanup step once you're done with your processing the request. Okay, so just to recap, it's a pretty confusing diagram. So a request comes into the web server, it gets sent to the Whiskey server. The Whiskey server spawns a worker to handle that request, which is your Flask application. The framework automatically pushes the application context and the request context onto their respective stacks. And then you use proxies within the view function to be able to access those contexts. And then once you're done using them, they then get popped from the stack and the response gets sent out. So this is kind of the whole request all the way through to the response. Okay, so that's kind of the concept of how things work. I now want to get into an example of a common issue that can occur with the application context when you're doing testing. So the example that I'm going to show is using Pytest, which is a popular test framework in Python. I would say between like unit test, which is built into this Python standard library, and Pytest, those are kind of the two most common test frameworks. So here's an example of a test function in Pytest. So this function is testing what happens when you send a GET request to your home page. So it's making the request via a test client. You get the response back, and then you check if the response has the correct status code. In this case, we're hoping it's 200 OK. And then we're checking, you know, for a specific string in the response data as well. So I should mention, you know, I'm a huge fan of Pytest. I highly recommend learning how to use it. I would also recommend Brian Ocken's book, Python testing with Pytest if you're interested in really diving into how to use Pytest. Okay, so this is the test function that we're concerned with. The one thing I want to point out here is that there's an argument being passed in, which is the test client. And so let's take a look at the next slide of what that means. So the test client is actually the name of a fixture. So fixtures are one of the cool features of Pytest. And fixtures are used to initialize your tests into a known state. And this really helps in making sure that your tests are running in a predictable and repeatable manner. And one thing that's really powerful about fixtures is that you can actually call multiple fixtures to help initialize a test function. And you can even have one fixture calling another fixture to help initialize things. So it really provides a lot of structure to get things in the right state in order for your test functions to run properly. Okay, so in this case here, so back up a little bit. So in Pytest, your fixtures are going to be defined in a file called conftest.py. And you use this decorator, pytest.fixture, to note that this is a fixture. And each fixture has a specific scope, which is, when this fixture should run. And this is a very powerful feature of Pytest. I think if you start to dive into Pytest, this can really become useful to have different scopes for different fixtures. So this fixture is creating a Flask application using this create app function. So this is assuming that our Flask application is using the application factory method to create a Flask application instance. So with that app, we then can create a test client, which is what we are then returning. And by returning that, that makes it available here within the test function. So this fixture gets called first to create the test client, and then that test client can be used within our test function. So you got the fixture initializing everything for you so that the test function can run like in a known state. Okay, so let's say in our fixture, we want to add a log message. And this might be something you'd be interested in doing if you're trying to figure out, well, when is this fixture running, relative to my test functions. And so in this case here, we want to add a log message to say, oh, here we are, we're in this test fixture. And as we learned up before in those diagrams, we have access to the current app proxy, which is what we can use to access the application context. And one of the things that's stored in the application context is the logger. So we can call current app, and then that allows us to access the logger, and then we can log in info message. So everything probably looks good here. We're using the proxy like we should to access the logger, which is part of the application context. But what happens if we run this? Oh, we actually get an error. So the error that we're getting is a runtime error, and it tells us that we're working outside of the application context. So this may seem strange at first because we're using that current app proxy, to point to the application context. So that seems like we're following the right steps, but something's wrong here. And let's go back to this diagram if we try to figure out what's wrong. So we're using this current app proxy, but it's actually not pointing to anything because there's nothing that's been pushed to the application context stack. So remember, we're in a test function, so the Flask framework isn't taking care of pushing things onto the stacks like what happens when there's a request that comes in. So we're trying to use the current app proxy, but it's actually not pointed to anything, which is why we get this runtime error. So how can we solve this? So we can update the fixture to actually kind of simulate what happens with the Flask framework when a request comes in. So before we want to access the current app proxy, what we do is we establish the application context, and then we push the application context onto the application context stack. So we're pushing the application context prior to accessing the logger. And so now once the application context is pushed onto its stack, this current app proxy is going to be pointing to a valid context, and we'll be able to use the logger here as we expect. And then once we're done using this proxy, we want to clean up, and we're going to pop that application context from the stack. So this is pretty similar to what happens in the Flask framework when a request comes in. There's the whole process of pushing the application context onto the stack, and then once you're done using the context, you're popping it from the stack as the cleanup step. So this approach, is kind of like procedural approach here, I think is really nice to figure out how this is supposed to work in terms of pushing and popping relative to the stack. But in terms of like a long-term solution, I think a better approach in this case would be to use a context manager. So that's this with statement here. So by using this with statement and saying with the application context, it's going to take care of that pushing the application context onto the stack and then cleaning up by popping from the application context stack once we're done. So with this simple with statement, we can then safely access this current app proxy. So this context manager approach, I think, is a really good long-term solution for fixtures when you're dealing with Flask. So in conclusion, just want to say, both the application and the request context, they're used to provide the necessary data when you're dealing with requests or CLI commands in Flask. Most of the time when you're working with Flask, these will just be taken care of for you. But I think they're really important to know because you're going to run into problems with these contexts, especially during testing. And by really understanding how these contexts work, you're going to really be able to solve a lot of common problems that can come up during development and testing. So thank you very much. Also just want to mention that I have 2 blog posts that cover this topic. This first one here provides a nice introduction into these contexts. And then the second blog post provides a deep dive, and it covers a lot of the diagrams that are in this presentation. It also dives into more detail about the context local implementation and provides an example of that. So if you want to learn more about that, I definitely recommend these 2 blog posts.